Hello everyone, I welcome all of you for second session of CAENexus basic training. So just a quick recap about earlier session. So in earlier session we have seen what is CAENexus, some details about CA geometry. We have seen what are abstract classes, what are abstract model, some terminologies like what is non-manifold model, what exactly relations are, and we have seen the overall workflow of CAENexus. Now, in this session, we'll see some more details related to abstract model authoring. So you know what exactly the abstract is, and we have seen the significance of abstract in CAENexus workflow. That is to capture the knowledge and from automation point of view. So in this session, we'll see some more details about the abstract entities, that is classes, their closure entity and relation. And we will try to understand how the simulation physics or the information is getting transferred onto the real geometry. So that would be the agenda for this session. Before starting the session, maybe I'll quickly cover one point which we have already seen in our earlier session, that is building block of abstract model. So there are four building blocks: component, class, relation, and attribute. And you know that attribute are the behaviors that user attaches on class or the closure entities. For example, element set related attribute, we specify or attach it on a solid class. Similarly, maybe mesh related attribute or the contact related attribute, we can specify on the different classes based on the requirement. So this is what we had seen in the first session. Now let's see the abstract entities in detail and try to understand how the simulation physics or the information is getting transferred to the actual geometrical part. Let's start with the volume class. So all of you know what are the classes. So classes are the entities which are having some specific dimension but not having any specific shape until we are combining it with a particular CAD model. So you know that the CAENexus workflow, it divides the engineering task into two roles, that is CAD specialist and the CAE analyst. So let's say CAD specialist has created this small assembly. So this assembly contains some parts like your left hub, right hub, there is some pin structure and bottom plate. And we have assigned steel 1430 class on these three parts, that is left hub, right hub and pin structure in the CAD modeler. And the analysts, they have used that class, that is steel 1430, to set up the simulation related physics with the help of attribute. So in this case, analyst wants to set up element set related physics. So analyst has created element set attribute with the help of steel 1430 in the abstract model file. Now let's see what happens when we combine the CAD model with the abstract model file. So when we combine, we get the simulation model, that is the real model. And in class tab, if we select the steel 1430 class, then it will highlight the respective parts on which we have assigned steel 1430 class in our CAD model. When we move from class tab to component tab, then the attribute specified on the volume class, that is steel 1430, it will get transferred onto the respective volume component. So in this case, the element set attribute will get transferred onto these three components, that is left hub, pin and the right hub. When we move from component tab to model tab, then the attribute from volume component it will get transferred onto the respective volumes. So in this case, it will transferred onto these three volumes representing three components. Just to summarize, the attribute specified on the volume class, it will get transferred to the respective component first, and after that, it will get transferred to the respective volumes. Let's now take one more example of volume class. So solid is the volume class and that is assigned to the four CAD parts, that is left hub, your right hub, your pin structure and the bottom plate. And we have used, or the analyst has used, that class to set up the physics with the help of attribute. So let's try to imagine on what geometrical entities the attribute will get transferred in the simulation model. So you know that we specified the attribute on the solid class. So from class, it will go to the respective component. So it will go to the four components, that is left hub, pin structure, right hub and the bottom plate. And from component, it will get transferred to the respective geometrical entities. That is, here in this case, it will get transferred to the respective volumes. That is four volumes, each volume corresponding to each component. So you can see here we have specified the attribute on the volume class, that is solid class, and that's why it is highlighting the parts on which we have specified that solid class. When we move to the component tab, then the attribute from the class tab will get transferred onto the respective components. So it will get transferred onto the four components, your left hub, pin structure, right hub and the bottom plate. And after that, from components, it will get transferred onto the respective volumes. That is four volumes in this case. So just to summarize, the attributes specified on the volume class, it will get transferred to respective component first, and after that, it will get transferred to the respective volumes, that is respective geometrical entities. We have seen the volume class. Let's now see the child entities of volume class. So boundary is one of the child entity of volume class and it represents the two-dimensional abstract entity which bounds the three-dimensional volume, but it does not include the interface of your volume class. So let's now understand how the attribute get transferred from the child entities to the actual geometrical entity. Let's say contact is my volume class and that is assigned to these two CAD parts, that is left hub and right hub, and analyst, they have specified the attribute on the child entity, that is boundary of the contact. So let's see how the attribute will get transferred from this child entity to the actual geometrical entity. So when we create the simulation model, if we select the boundary of the contact, then it will highlight the respective surfaces. So you know that boundary means it is a two-dimensional entity which encloses the volume, but it does not include the interface of that volume. So in this case, it will just select the 2D surfaces of that class, excluding the surfaces which are in contact with the other classes, that is the bottom plate and the peak. So it will not consider those interface surfaces which are between your hub and the pin or hub and the bottom plate. Now, when we'll move from class tab to component tab, then the attribute will get transferred onto the respective components. And when we'll move from component tab to model tab, then the attribute will get transferred from respective component to respective geometrical entity. So in this case, it will get transferred onto all the surfaces of these two hubs, that is left hub and right hub, excluding your interface surfaces. Now, as I said, boundary of the volume class is a two-dimensional entity, and that's why when it will get transferred to the geometrical entity, that geometrical entity would be a two-dimensional entity. So that's why here it's getting transferred onto the surfaces. Just to summarize, the attributes specified on the enclosure entities of volume class, that is boundary in this case, it will get transferred to the respective component first, and after that it will get transferred to the respective geometrical entities. Similarly, let's see one more closure entity of volume class, that is interface. So interface is a two-dimensional abstract entity which is a three-dimensional volume class will share with other three-dimensional volume class or the classes. So it's actually the common entity between the three-dimensional classes. Let's say contact is my volume class and that is assigned to these two parts, that is left hub and right hub, and the analysts, they have used the interface of contact for specifying the attribute. So let's see how the attribute get transferred to the geometrical entity in simulation model. In simulation model, when we'll select the interface of contact, then it will highlight the respective geometrical entities. So as I said, interface is a two-dimensional entity which is common between your volume classes. So here these four locations are common between your volume class and other classes. So that's why these four locations are getting highlighted. Now, when we'll move from class tab to component tab, then the attribute from interface of volume class will be transferred onto the interface of corresponding volume component. And when we'll move from component tab to model tab, then the attribute from the interface of volume component will get transferred onto the actual geometrical entities. So in this case, those would be surfaces. So the surfaces which are common between your contact class and the other classes. So that's why the surfaces corresponding to these four locations are getting highlighted. Just to summarize, the attributes specified on the enclosure entity of volume class, that is interface in this case, it will get transferred to the respective component first, and after that it will get transferred to the respective geometrical entities. So that's all about the attribute transfer in case of volume class. Similar concept is applicable for surface class also. So all of you know surface class is a two-dimensional abstract entity and it does not have any specific shape till the time we are not combining with any CAD geometry. So let's understand how the attribute transfer takes place in surface class. Let's say fixed 2D is my surface class and that is assigned to the bottom surface of this green plate. And in abstract model file, that class is used to set up some simulation physics with the help of attribute. So let's see how the attribute get transferred from class to the actual geometrical entity. In simulation model, fixed 2D class will highlight the respective geometrical entity. Now, when we will move from class tab to component tab, then the attribute specified on the surface class will get transferred onto the respective surface components. And when we'll move from component tab to model tab, then the attribute from surface components, it will get transferred onto the respective geometrical entities, that is surfaces. Just to summarize, the attribute specified on the surface class, it will get transferred to respective surface component first, and after that it will get transferred to the respective geometrical entity. Whether it's a volume class or surface class or any other class or any other closure entity, the transfer of attribute will happen in a similar way. That is, firstly, it will get transferred onto the respective component, and after that, it will get transferred onto the respective geometrical entities. Let's now see some more details related to relations. So we have already talked about relation in our earlier session. So relation is an abstract entity which represents the common entities between the classes, and the dimension of relation is based on the dimension of the classes which are involved in that relation. So let's now see how the attribute transfer takes place in case of relations. Let's see a relation between three-dimensional classes. So let's say contact and solid, these are my two classes. So contact is assigned to these two CAD parts, that is my left hub and right hub, whereas solid class is assigned to pin structure and this green bottom plate. And in abstract model file, we have used the relation between contact and solid class to set up the physics. So let's see how the attribute get transferred to the actual geometrical entity. So when we create the simulation model, then the relation between contact and solid will highlight the respective geometrical entity. So you know that the relation will give the common entities between two classes, and that's the reason that these four locations are getting highlighted in the simulation model. Again, the dimension of this relation, it depends on the dimension of the classes which are involved in the relation. So corresponding abstract entity for 3D relation is a two-dimensional entity. Now when we'll move from class tab to component tab, then the attribute will get transferred onto the respective components. And when we'll move from component tab to model tab, the same attribute from the components will get transferred onto the respective geometrical entity. That is the surfaces belonging to these four locations in this case. Just to summarize, the attributes specified on the relation between 3D class, it will get transferred to the respective component first, and after that it will get transferred to the respective geometrical entities. So concept wise, whether your class is a 3D class or your class is a 2D class, or you are using any closure entity or you are using any relation, your attribute transfer will always take place in a similar way. The attribute will get transferred from classes to the component and from component to the respective geometrical entities. Same thing is applicable to a relation between a three-dimensional class and two-dimensional class. So for example, let's say solid is my three-dimensional class which is assigned to this green plane, whereas fixed 2D is my two-dimensional class which is assigned to the bottom surface. So let's see what happens in the simulation model. So in the simulation model, when we'll select the relation between solid and fixed 2D, then it will highlight the corresponding face use. So in case of relation between 3D and 2D class, the abstract entity is not having any specific dimension, but the abstract entity is a face use which is pointing towards or belonging to the volume class. Now when we'll move from class tab to component tab, then the attribute will get transferred onto the respective components. And when we'll move from component tab to model tab, then the attribute will get transferred to the respective phase uses. Just to summarize, the attributes specified on the relation between 3D class, it will get transferred to the respective component first, and after that it will get transferred to the respective geometrical entities. Now, about face uses, we have talked in our earlier session. So you must be remembering that we had considered a cube structure, and if I take any face from that cube structure, then it will have two face uses, one pointing inside the cube and one pointing outside the cube. So same applies to this relation, that is relation between your 3D class and 2D class. So the relation here is not having any specific dimension, but the abstract entity is actually a face use which is pointing towards your volume class or which is belonging to your volume class. Just to summarize, the attributes specified on the relation between 3D and 2D class, it will get transferred onto the respective component first, and after that it will get transferred onto the respective geometrical entity. So in this case, it is a face use. Here is a summary chart which shows how your attribute get transferred from abstract entity to the geometrical entity. Just remember that whatever may be your abstract entity, whether it's a 3D class or 2D class, the relation, or maybe the closure entities of classes or the relation, always your attribute will first transfer from abstract entity to the respective component. After that, it will get transferred from respective component to respective geometrical entity. So that's all from this session. I thanks everyone, and if you have any queries or question, then please feel free to contact at support@novusnexus.com, and we will get back to you accordingly. Now in next session, we'll see some details related to productivity improvement tool in CAENexus, and we'll understand how one can increase the efficiency in CAENexus workflow. Till then, have a good day. Bye.